Hey folks, Chuck Black here. We are doing 52 weeks of Python and we are in week number 39. And in this lesson, I'm continuing our discussion of Flask. The first thing I'll be talking about is the description of the code that does displaying the information and also monitoring information. So how do I do discovery? How do I do monitoring? And so we're going to look at that actual code and figure out how it does what it does. Then I'm going to bounce forward and we'll look at an enhanced version of this that not only does discovery monitoring and discovery and monitoring, but I've added doing scanning as well. So I'm using port scanning to scan the ports of the devices. You can see here is my output where I'm actually listing the open ports for the various devices. So I'm doing basically the same thing as I was doing before in terms, and you can see the colors changing here. As I get the status, here's my monitoring program. I do scanning periodically, but in general, the added benefit, as you see over here, are the open TCP ports that I talk about. In addition to that, I mention in my code how I have reorganized things so that I have my simple host discovery and monitoring files right here, and I got rid of the other stuff, and then I have my Flask with port scan module or package, and inside it I have modules that do display scan, monitor scan. The server is exactly the same as it was before. All I've done here is I've added scanning functionality. Lastly, I am going to talk about a couple things that I added a long time ago, like almost 10 months ago when I was first contemplating doing this class, and that is I created a Flask service that handles get interface counter requests as well as getting inventory requests. So we look at this Flask service that I created and at this, and I have this little application that prints out interface counters in a mildly interesting way, not as nice looking as this, but it's a little bit interesting, so we'll look at that. And in addition to looking at our interface counter data, we're going to want to look at our inventory data. And as you can see, I don't have an application that goes and queries the inventory data and prints it out. That's because we're going to use a different mechanism for looking at that data, and that mechanism is an application called Postman. This is a very popular tool that we use who are creating a web application software, and it basically allows you to make an HTTP type of request and send it and get the output from it and examine that output and even store what you've done into these collections. And so we're going to look at how to do that. So that's what we're going to be talking about. Hopefully it will be interesting. It's a lot of stuff that bounces around a little bit, but hopefully you'll be able to make sense of it and learn a little bit. So let's get started. Okay, so let's look at what this host monitor application does. Remember, it's the thing that's actually going out and discovering devices. It is monitoring devices, and it is using our host server Flask application for storing the data so that then this other application host display can get the data and display it as you see over here on the right. So let's look at host monitor and see what it does. So I'm going to scroll down to the bottom. You can see it's only 107 lines of code, and some of this are extra. Basically, it starts out just calling main, and it's handling the keyboard interrupt so that I can stop it at any point in time. What does main do? Well, main basically has this while loop that it's going to do forever, and the only way that it ever exits is, you guessed it, via a keyboard interrupt. So let's look at what it does. Periodically, if the host discovery time has elapsed, then it is going to call into discovery and do its discovery. So if there are new devices on the network, that's where it will update this list. And as you can see, it has actually grown since the first time that we ran this. And in fact, maybe what I'll do right now is I'm going to stop this, and I'm going to go and I'm going to stop this, and I'm going to stop the server, and that will cause things to get reinitialized. So I'm going to run the server, And now at this point in time, I'm going to actually run this host display, and you'll see that there's actually nothing there. And now I'm going to go and I'm going to run the host monitor. And host monitor will begin to run. It's done its ARP discovery. You can see that it didn't update actually until after we had already done the refresh. So now it should have some devices. You can see I really should put a number here, shouldn't I, so that we can know how many devices there are. But if you just kind of eyeball it, and you can see right about here, this is how many we have. Maybe the next time we run discovery, there will be more devices. But let's see, we run discovery. Periodically, I have this discovery interval. Let's see what that's set to. It's set to every 5 minutes. So if I've blabbed on long enough for it to be 5 minutes, it will have run another discovery. Maybe it will discover more devices, maybe not. But the main thing that it does in here, besides periodically updating, is it goes through and it's going to go and it's going to get hosts. We'll look at that in a minute. And then it gets and iterates through all of the hosts. Again, this is just a typical way that you loop through a dictionary in our situation. And you do that by calling items. That gives you the key and the values. I guess I could have just said .values and then I wouldn't have needed to do this, but maybe I'll leave this in there for now so that you can see, okay, yeah, if you don't care about the keys, then you can just say underscore and it won't care about them. Basically what's going to happen is I'm going to ping the host and then I'm going to do an update on that host. So that will update the either the fact that it was unsuccessful, or it will update with the new last heard time. And then it goes to sleep. And again, this isn't a true interval. Just like in Quokka, what it's going to do is it's going to sleep for some number of seconds. In our situation, once it's done, it sleeps for 15 seconds. So if it takes 20 seconds to go through doing the ping of all of the devices that it knows about, then the total cycle time will be, can't even remember what I said, 30 seconds. 30 plus 15 would be 45. Did I say 20? Whatever, you get the idea. It's just going to wait for the maybe this is monitor wait time, I should have called it. But it goes through and does this loop, and it does it forever until somebody does a keyboard interrupt. In fact, I'm going to take a minute now and I'm going to actually get rid of this and we'll see if it works. All right, I did successfully change that. I've actually, in all my Python time, which admittedly hasn't been all that much, I mainly Java, C++, C, etc. in my long years of writing software, but in my shortish Python life, I've never used .values, so this is the first time I'll have to change the other places that I've done that as well, which I think there's only one or two. Anyway, so now it's doing ping host and update host. Actually, let's start at the top and let's go look at what discovery does. So I'm going to do Control B to take me to discovery. Now, this is exactly what I did before in our Scapy code that we did. We did a Scapy example. One of the things I did was this ARP ping, which has actually a function built in. I can call ARPing, and it will do pinging for this network, which is my subnet. And then I am going to be printing out the summary. And then for the actual answer, I'm going to iterate through it. And for every answer, I'm going to extract the payload to get the IP address and the MAC address. From the IP address, I'm going to get the host name. This is something that's in Quokka, but you may not have seen before, but I'm using sockets. In fact, you want to sneak peek to know all the things we're using in here. Subprocess, I use that to do a ping. Socket, I use it to get the name. Scapy, I use to do my discovery. And requests, I use to actually make the requests to my host server, my service, the thing that is right. Let's see if I can get that. I can't get that from there. Let's see if I can get it from here. Yeah, this is my, I need to do requests in order to do this. So that's the library that I use for that. So let's go back to my monitor and let us look at, first why don't we just go through these in order. Let's look at get host. What does get host do? Well, I do a request.get. Here's my URL. Notice hosts. That's going to be the same as this hosts right here. And I'm doing a get. And a get returns that global host. So when I'm going through monitor, I'm going to get my JSON is going to actually be the data structure which has all of the hosts in it and which you see printed over here, just to give you an idea what's in there. And you can see we've discovered a couple more devices the second time that we did that. Anyway, so that's basically what we do. I'm using the request library. Request is very common. It's very simple and easy to use. I can do a .get, .put, .post, .delete, all of those things, and I can pass in a lot of different information, including the URL. I can pass in parameters. I can pass in JSON data. We'll see that in just a second. But right now, what I'm doing is I'm just doing a get. I don't pass anything in, and I get back the JSON data. Now, what does discovery do? This is what I was beginning to talk about, and I'm returning to it now. I've gotten the answer from my ARP ping, and that contains all of the devices that have been discovered, including the IP address is in the payload, the MAC address is in the payload. Since I have the IP address, I can say, get me the host name, and so I get the host name. If it throws an exception, meaning it can't find it, then this is going to actually end up setting my host name appropriately based on, it's going to be the actual IP address. I set my last heard to this value, and then I go through and I set my host dictionary. I create my host dictionary, which is going to have an IP address and the MAC address appropriately. The host name I take from this host name thing that I got back from the socket library, get host by adder. I'm going to send the first thing. If I had to create it myself, it will just be the IP address. I set last heard and I set availability to true because I think that it's actually available. And then I'm going to call update host. What does that do? Well, let's take a look at update host, which happens to be right here. Basically, remember my request library. I'm now going to do a put. Let's take a look at what the put looks like. It's really the most interesting thing that we'll do here. In my request.put, one of the parameters that I can pass, the keyword is params, and I need to pass in a dictionary, and a dictionary is going to have the actual keyword that will be used and then the value that it's going to be used. And so if I look here and I look at my request, this put request is going to have this data in it. I happen to choose that both times that I've looked at it, but here's my hostname equals desktop whatever, and that is exactly what's happening right here. I'm passing it in as a Python dictionary. It's one item. One of the items in this dictionary is hostname, and its value will be the actual host name. Now the last thing is going to be the data, and data is going to be this host object. What is the host object? Well, when I did discovery, it's going to be this thing right here. When I do ping, it's going to be a different thing, but it's going to basically have the same data. And here I'm looking for my response code. If it's not correct, then I know that something is wrong. And if I successfully do it, then I say updated host status via REST API. We should be able to see some of that stuff right here. I tend to get on my Roku streaming stick all the time, don't I? Here's updating my Ring, my doorbell. So you can see that that's what that is doing. Now the other thing that we did down here in main is after discovery, I go through this loop where for every host, I do a ping and then I update it. We've just looked at update host. Let's see what ping host actually does. It's pretty short and sweet. I'm calling into subprocess.checkOutput. Basically what this does is it allows me to get the output for the command that I'm doing now. As it turns out, I'm not actually even looking at the output, so Normally, like in my Quokka application, I get the response time from this, but here I just care if it's successful. If it's not successful, it's going to throw an exception, and this is what it actually throws, and I'm going to set availability to false. But otherwise, I was passed in this host dictionary, which is going to have IP and MAC address, etc., which is what I used when I made that ping request. If it succeeds, I will continue to this next line where I set availability equal to true. I will set last heard to this value, and that is what my ping host does. Remember, I do ping host, and then I do update host. And update host we looked at before. It's the same thing that we call after discovery. I do a put, and I'm passing in the host name. And in this situation, it will never be creating something new. When I'm doing a ping, it will just be updating it with the appropriate value. And that is what I pass in there. So let's just review what this does. It's just a loop. It goes through this loop, and if the time is expired for doing discovery, it does discovery and sets the last discovery. In either case, it gets all the hosts, and then it iterates through the hosts, getting the values. Remember, that's just the host object, and it does a ping, and then it does an update, and then it sleeps for a certain amount of time. And that's what you see running over here. And that is what updates the data that's actually in this, that's being held by the Quokka server service. So that is what you see right here. That's the REST API for updating it. And then the host display, which we'll look at next, is what actually draws this nice table. Okay, let's look at host display. Remember, host display is the thing that just prints out this table and does the colors and updates it based on whether the actual data that it's printing is new or whether it's the same as what it was before. So let's look at the code that does that. Oh, and by the way, remember, host display, all it's doing is it's getting the data from our host server Flask application. So let's look at the actual data. Now, the main application for host display is just this. All it does, it's going to keep track of previous hosts because we want to do the color appropriately. It's going to go and get hosts. It's going to print hosts. And then it's going to set previous host equal to host so that we can, that's how we distinguish between whether we want to do it a bright green or not a bright green. That's what the previous host is for. Now we do a print host. You'll notice that we're not waiting or pausing in here, so you may wonder about that. The answer of why we do that is because that code is actually down here, and that is inside print host. So we could argue about whether that code should be in print hosts or elsewhere, probably because we're printing this countdown timer here, then it needs to be in print hosts, but that's basically what we're doing. So let's look at print hosts. That's the main thing that we do. So the first thing that we do, and this is, there's not anything really new except the fact that I'm kind of diddling around with the screen to keep it like this. Normally when you print stuff out, it just ends up scrolling up the screen, kind of like what you see here. It just scrolls and scrolls and scrolls forever, or over here with our Flask application. So those all just keep updating forever. This one seems to just print, and the question would be, how do I do that? You can look online. There's multiple ways to do that. What I end up doing is I call clear to clear the screen, and I do that if it's POSIX, if it's not POSIX based. In other words, if it's not a Linux type of system, then we do CLS. That would work on Windows, I believe. Of course, this takes a while to figure out how exactly is the data going to come out that I'm trying to print it, but I want to print out the column headings for this. And then what I do is I'm going to go through, I have my hosts, and so I'm going to go through and I do host in host.values, and I'm going to go and print out every one of these hosts. So I'm first going to say, is the host not available. And if it's not available, I print it in red. And as you can see here, this laptop is not, it says it's a desktop, it's really a laptop. It's not, doesn't respond to pings is what that means. I'm able to discover it, doesn't respond to pings. Up and here, once again, my Google Nest device went down. It's not really down at all. It's just that my timeout is really short, and so I can play around with that if I wanted it to stay green, which I probably would, but it actually looks a little bit nicer going red and not red. It looks more realistic. So if it's not available, then I decide to set the color equal to red. This is how I'm going to end up printing it out. And then the second thing that I do is I check to see if the host is in the previous host and if they're both the same. So I'm looking at my current host and is it equal to the previous hosts with that host name. And if it's equal to the same, then I just print it in green. That is the one that ends up looking dull compared to the other. And then if that's not true, that means that something is different. It's either new, meaning that this failed, or it's different, meaning that this failed. And if either of those is true, then I do light green. And then I print this out. And the way that we end up printing it out is we use this Colorama Library. You can see I found this online just over the weekend. When I implemented this, I can specify the first item that I want it to print is this 4 dot whatever, 4 dot the appropriate color. And when I'm done with the line, I set it back to white so that the rest of the data gets printed white like I want that column headings as well as this refresh timer. And I print it out and I go through all, that's just my for loop here, so I go through all of the hosts. And the only thing left to talk about is this, and that is my countdown timer. You can see I have a countdown timer that goes from 10 down to 0, and that's what I do implement this way. Again, I got this quite a while ago, but there's examples of this online, so I found somebody who had done this. I'm doing a range, so I'm starting at 10, and I'm ending at 0, and my increment is -1. Remember, you can have an increment of 1, which is the default, and it'll count up with your range built-in function, or you can have a value like 2 where it will skip, or 3, but in this case, the value that is the hop count is -1. So it starts at 10, and it goes down to 0, effectively. And when it gets down to 0, we exit our call, and that's when we go back and we do our next get hosts and then print hosts. And what do we do inside when we're printing it out? Well, these lines right here it's just updating this one line right here. So I'm not using, notice, don't get confused, I'm not using the Python print statement. I'm using sys.standardout.write. I'm doing a carriage return, which pushes it back to the beginning of the line, but it doesn't do a new line, so it actually goes to the beginning where it says refresh. The next thing I do is write, and this is what I write out every time. I'm writing the remaining number of seconds. Notice this F string, I have formatting of 3D, so it's using 3 spaces and it's expecting it to be a number. And so that is why we have that. So I have 3 spaces for that. And then flush causes it to be written out. So unless I'm not doing a new line or anything, it doesn't think that it needs to print it out. So flush causes it to be printed out. And I sleep for a second and just do the countdown timer like that. And that's how we end up with this. When it gets down to 0, it goes back to the outer loop and it prints this entire thing again. Now, if you had 10,000 devices, this would probably be a very unpleasing display, but because I have a limited number of devices in my home, it actually ends up looking kind of nice. That is host display. So now just a reminder, this is what we've got going on here. We've got our Flask server who's sitting there waiting for calls to come in. And receiving get and put requests. In my situations, the get and put may be coming from host monitor, but only gets are coming from host display. The monitor is going out and doing its stuff to discover devices and then more regularly to ping them to see if they're alive. And then the host display is just gathering in, and that's this application is the monitor. Once again, I'm not at the bottom, so we're not seeing it update. And then the host monitor, the host display is actually what's doing this. That's what we've got. And that's how this application works. Okay, so I said that I was going to create, or I had created a version of this that didn't only monitor and discover, but also did scanning. So this is what the current thing that we just looked at looks like. And this is what the version that the scanning looks like. As you can see, between the two, there's not really any difference other than I changed the name of it to scan and host monitor to scan and host display, etc. Now, in actuality, in terms of code, host server stays exactly the same. Host display scan is going to show the open TCP ports in order to make it more viewable. I got rid of the MAC address. And then the piece that does actually the work, the host monitor scan, all I did was I added functionality to do a port scan periodically. And what do we end up with when we do that? Well, the output here is showing the open TCP ports using Nmap to do a port scan on each of the known devices. It tries to find out if any of the ports are actually open by doing whatever it is that Nmap does with its generic non-root requiring TCP scan, and it finds certain ports are open. So you can see on this device here, not even sure what that one is. There's 4 ports open. On this one, my RE220, I actually don't even know what that one is. My gateway, I do know what that one is. That's my router, my wireless router. My Lenovo Yoga Home, that's this laptop that I'm running on. And I don't know what this one is that has ports 22 and 80 open. It might be related to this one here. I'm not sure. But you can see those ports are open. Hopefully they're secure. On the rest, the ports don't seem to be open. But this could give you a decent, if you're trying to do a security scan periodically and just keep track of it, then this would be a pretty cheap and inexpensive and easy type of application to be running pretty regularly. You could run it even less often than I did. As I mentioned, the server, the Flask server stays the same. And here, if I were to scroll up, then I would eventually get to a point where, okay, there I've done discovery. I'm going to keep scrolling up. Hopefully I will find some spot where I've done the port scanning. There we go. So port scanning, you can see this is where I begin. I retrieve the host, I scan. This one I scanned okay and I found nothing. This one I found okay, I scanned nothing. This one here, I seem to have gotten a failure on my scan. So for whatever reason, I didn't get results. For this device, I did find that I found those 4 ports were open. And for this RE220, I found those 2 ports were open. And if I keep going down, for my gateway, that's my wireless router for my home. I have these ports that are open, etc., etc. This is my Lenovo Yoga. This is my laptop that's running Windows 10. So those ports are open. So anyway, you get the general idea about what's going on. Let's take a look at the code and see what it does. So here we are in the code. Now we were looking earlier at M05 Flask and we looked at host display, host monitor, and host server. You'll notice I have some other stuff in that package, in that folder, but I haven't gone over those yet. Hopefully I'll have a chance to go over those soon. But the main Python modules would be host display, host monitor, and host server. Now what I did was I just created a brand new Python package in which I'm storing the 3 important files that I need, the Python modules. I mentioned host server is exactly the same, so we don't have to go through that. Let's look at host display scan, I'm calling it. It's exactly the same, except I've gotten rid of MAC address, so there's real estate on the screen, and I added this open TCP ports. And as you notice, I've got room for a certain number of TCP ports. It will print further as far to the right as necessary. So, if you have a ton of them, then it will go to the right and it will eventually wrap and begin to look ugly. And so it's probably not the best solution for output. What I might want to do is get a string version of this list and then truncate it somewhere or do something different. But be that as it may, here you can see what I'm doing in terms of printing stuff out. I am going to be printing that out. I've got that right here in my column title, and then if you look down here to my print is almost identical, except here I'm doing open TCP port. So I'm assuming that there's a field in my dictionary a key called open TCP ports. I'm not actually checking for that, so I need to make sure that that is there all the time. And so I believe that in my monitor I have changed stuff. So let me look here for open TCP ports. So here is where I'm scanning. There's one version of open TCP ports. And let me go back to the other one. When I discover a new device, then I create open TCP ports with nothing there. So I want to make sure that it's always there, because my code that prints it isn't smart enough to make sure that every one of these things it tries to print is available. So in a real live application, you'd probably want to make sure that it has all of these or do something different. So let's look at scan and see what scan does. Let me go down to the main part of the application. So this looks pretty much the same. I used to have last discovery. Now I have last discovery and last port scan. And what I'm going to do here is my discovery. I'll do a discovery the first time through, and then every time I reach the discovery interval. When I'm done with that, I'll go and get my hosts, and I'm going to do a couple things. First thing I'm going to do is I'm going to go ahead and do the port scan. If it's time to do the port scan, now my time interval, as you'll see for port scan, is like every hour or something. And the reason is it takes a long time to do, and it probably doesn't change all that regularly. Of course, you could set this to whatever you wanted. My discovery interval here is, 10 minutes or so, and monitor interval is a minute. But that is in my main code here. This is what I'm doing. I'm going to do my port scan if it's time to do it, and this part is exactly the same as it was before. I'm going to do my ping of the host and then update of the host. So you see that everything's the same, except I've added this extra port scan stuff, and that gives me the advantage of having this stuff displayed. Now let's look at port scan hosts and see exactly what that does. I mentioned it takes a while. I also mentioned I just copied this code from my nmap code. So what I'm going to do is I'm going to go through every host, and I'm going to make sure that the host is available and that it has availability and that it's available. And if it's not, then I'm going to just ignore it. Otherwise, I'm going to get the IP address for this host, and I'm just going to do what I did in my nmap example back in whatever week that was. I just create my port scanner. So if you want to know what this is and what it does, I advise you to go back to whichever week that was. Look for the week that's titled nmap and look at that. So I create my port scanner object called nm, and then I do a scan of that IP address, and I'm looking at ports 22 through 1024, just because that's what some of the examples said. I suppose that's in a reasonable range. So those are the ports that it's going to be scanning, and then I'm going to come in and I'm going to say try NMIP. All I'm going to be doing here at this point in time is I'm checking to see if this IP address exists in NM. Now remember, if you recall, when we went through, I actually had an nmap addendum where I discovered exactly what they did. NM is actually an object, right? It's not a dictionary. And so when I get this object back, the way that you typically use an object is you say dot whatever, whether that is a method or whether it is a member data. But what we have here is this type of syntax, and what that's going to do is it's going to call into the Python get item method that has been defined. I think it's underscore get item. It might be underscore underscore get item underscore underscore. I can't recall for sure, but basically that allows us to pass in an IP address, and I'm treating this as if it was a dictionary. That's what that is doing. And again, look at the nmap addendum if you want to see what that does. But if it's there, then everything's okay. If it's not there, then the nmap scan failed and we didn't get any data back. And so at that point we continue. And if we did, then we just basically take nm at the key of IP address, and we get all the open TCP ports. That gives them to me. And at that point in time, I have host. It has all the host stuff in it before. So all I'm doing is I'm updating this particular item in host with the open TCP ports, and then I'm calling update. And my update is, I believe it's exactly like it was before. Yeah, I'm just calling in to do a put, and I'm passing in the host and giving as a query parameter the actual host name. And the end result is we end up with something like this, that it actually is going out, and every hour or so, I think that I'm not updating this, so I don't know if it's done anything since then, but it is every hour it's going out and scanning the open ports. I think that it takes probably 5 minutes-ish to do this many devices. I can't, don't count that as actual fact. I can't remember, but it is in that ballpark of 5 minutes, and that's how long it would take. That's why we do it not regularly. And in fact, while I'm on the topic, what it probably means is that in a real good implementation, what I would do is I wouldn't be doing these things sequentially. In other words, I wouldn't be, down in main here, I wouldn't be doing port scan hosts and then ping and update hosts. I would be running these in separate threads. And that actually is what I might do in Quokka, where I do have threads. Maybe we'll do this when we get to discussions of concurrency. But for right now, we're just doing it the simple way. All right, so that is the port scan version of this host application, where you have a server and you have a monitor and you have the display functionality. Okay, now a couple more things that I want to show you here. So we were in M05 Flask, where we had display, monitor, and server, and we looked at that, and I've cleaned that up. I've moved things out so it only has that. Host discovery is what I wrote initially to play around with discovery, but then I ended up putting the discovery code into monitor. In Flask port scan, I had the scan version of that, which is an upgrade to this. It's inclusive of that. The things that I moved out of M05 Flask, I've moved down into M05C, which is doing interface and inventory. They're not related, but it's code that I wrote like about 10 months ago for this, and I've just now gotten into it, and I'll show you what it is that it does. So basically, I have a server. My interface inventory server looks like this. I'm going to have two main sets of functionality. Two main endpoints. One is inventory, and what I'm going to do here is I'm going to return YAML inventory, or my JSON inventory, or my CSV inventory that I'm going to read. So if you've done my module 2 where we talked about files, then you know that there's code where we've done this. So this is nothing new, but this is what I am returning when this request is made. And I'm passing in a query parameter called type. That's probably not the best name because it can be kind of confusing. That's a generic term that we use, but that is what I'm doing, and I'll show you how that works. The second one that I'm doing is interface counters. Now this is totally different. What I'm going to do here is I'm going to go out and communicate with actual devices. So I am using Napalm in order to actually connect to the device and then to go and get interface counters. So that takes quite a while. Now the output for the interface counters, you can see it's working right here. This is basically me going out and getting it. Every 10 seconds I go out and get it. If you recall from Quokka et al. Or from our M04 networking, you can see this is going to pause for a significant number of seconds, maybe 10 to 20 seconds while it goes out and gets it. This number here is going to change. In fact, all of the ones on Ethernet 1, or at least a couple of them, are going to change when we eventually get our counters back. And I looked away at the wrong time. I'm hoping that that actually changed because I rewrote it. You will have looked at it and you can probably tell me. But yeah, so that's what that does. It goes out and gets that. And this begins to grow because people are using, this is again using the sandbox device. And sometimes we end up with dozens of different ports that don't really have anything going on. But Gigabit Ethernet 1 is pretty reliable in that it always changes there. I just saw it change. So we do know that that is updating and working correctly. Now, for the inventory, how are we going to exercise that? Whoops, the inventory, how are we going to exercise that? Well, I said that we're going to be passing in an argument called type, and that value has to be YAML, JSON, or CSV. How are we going to actually exercise that? I did not write a program to do that. Instead, you're going to need to learn about this. This is Postman. Now, there's other ways to do things like this. You can use curl if you want to use curl, but this Postman program is what I and many of my friends, when I've done lots of Cisco trainings in China and back east and things of that nature, we ended up using Postman to demonstrate a lot of different things. So I know that it's fairly popular amongst networking folks. So what is this? Basically, if you look right here, you can start from nothing and you can say, okay, I want to do a get. I'm doing it to localhost. What was my URL? It's inventory. So I want to get the inventory, and that parameter, remember I said, was type. And my type in this situation, CSV, let me change that to YAML and see what I get, YAML. And if I send this, then you'll see what will happen is I'll get the output back, and it'll be all nicely formatted, the JSON data that I get back. Now it's nicely formatted because I clicked on pretty and I said I want to see JSON output. If it was XML, it would be something different, but we're returning JSON. I put in my parameters here. This is where I put in my query params. I probably could have put, oh, I have it right here. So it filled this in for me, I guess. I actually don't know with Postman if you can fill it in here and it will pass them along or not. I do know when I change it here, let's just change this to JSON. Oh yeah, you can see down below that it is changing it for me. So I guess this is just recording what I am doing. And so if I send this for getting JSON data, and if you had an eagle eye, then you might have been able to see, let me move this over here. Let me send this again. You'll be able to see that something happens here. Did you see that? We just got another inventory request and returned the data appropriately. In fact, I probably could sneak and make this a little bit more. There's my inventory of JSON. Let me change this back to CSV. CSV, up it's just did the interface counter. So here I'm doing CSV, and you'll see it right here. Here's my type equals CSV on my server, and here's my data. You can see that it's actually got the different data that we did. We did this in the files class. That's where I got that inventory from. So what I've done, and you should know this about Postman, what I've done is I have saved things over into these collections. And so like here for Quokka, you can see while I was working on Quokka, I ended up creating a whole bunch of these because this was the easiest way for me to test things. Here's me doing testing of traceroute without having to run the actual front end. I'm able to test for doing sniffing of different Berkeley packet filter ones, heartbeat from a device, events, resetting of stuff. So here you can see I've done that. Now I've just started this one called Python 52 weeks, and you can see I've done CSV and JSON, but I haven't done YAML. Let me point this out to you. So I'm going to type in YAML here, and I'm going to do a send, you'll see it pop up over here. That's my type equals YAML. I got the data back. Now if I say, oh, that's cool, I want to save it, and I click that, guess what? I'm going to blow away this thing right here, my inventory-CSV. I don't want to save it as inventory CSV. So I want to go here and I want to say save as. All right. And now it's going to allow me to give it the name. So my request name is going to be, I forgot, what did I do? YAML. It's going to be YAML. And now it has selected this, but I need to select the folder that it's going to go into. And the user interface on this is really poor. If I've not selected anything, it won't allow me to do it until I come and show the folder that I want to use. But one clue right here, it says save to Python 52 weeks. That's my collection. So if I save it, you should see it just appeared right here, inventory YAML. And now what I can do is I can click on that and it will pop it up there. See, if I click inventory JSON, then it refills that in. If I do inventory CSV, then it fills in the CSV one. Let's see what happens if I do a send on inventory CSV, if I did this correctly. Yeah, it did. Okay, so let's review what we talked about. Now, we bounced around a bunch, and so I'm just going to touch on the things that we talked about. One of the things I mentioned was that I reorganized this code over here, so I now have M05 Flask, which only has display, monitor, and server in it. This discovery is left over and just has some code that it's not really in play for doing what we're doing over here. So that is what is in M05 Flask. In M05 Flask port scan, I have the same thing, but I've augmented my discovery and monitoring to do scanning as well. And this picture shows it, although all I did is change the name to host monitor scan and host display scan and added that. The code actually goes through and does one extra task periodically, and that is to scan the ports to get information about what TCP ports are open. So you can see I have been running this overnight, and I have a large number of devices actually that have been discovered, and these have those ports open. So that is what we talked about first, and was the description of host monitor and host display, which I hadn't talked about. So the code that actually does that, we looked at that. Then I did the host scan portion, and as I mentioned, it's the same thing. And then I described some things that I'd written quite a while ago, actually. One is getting interface counters, and so I created this inventory server. So this inventory server actually responds to inventory requests, and in that it just grabs stuff from these files, these inventory files. And there's a second request called interface counters, and uniquely this actually goes out and does the retrieval of the interface counters. So you can see I'm actually going out and using napalm to get those counters. So this is a little bit different than our host monitor, host display, and the host server situation. In the host server situation, you recall the host server itself didn't really do anything. It was just a repository for storing information. In my little interface inventory server Flask application, I actually do networking stuff in the middle of it. And so that's what that is, and that's what that's about. Just to remind you, we also talked about Postman, and I showed you how you can use Postman to get inventory information from your web service, whether that is, in this situation we're looking at inventory, but certainly you could get information about, in my situation, hosts and other stuff as well. So that is what we talked about. Hopefully that made sense. If not, as I say, give me a shout either via a comment or a question or something of that nature. Hope this helps you to understand Flask a little bit better. We'll continue with some more discussion of Flask in the next lesson. But until then, thanks for listening.